last video for the week. This is Parent Transformations Part 2. So go on. Sorry, I got a little distracted for a second, but there we go. If you look, these pictures are a little bit different. We're doing the other side of this parent functions handout. So in the previous video, we did this side with the quadratic and the absolute value and the square roots. In this video, we are doing cubic rational cubed roots. Okay, this is what the parent functions look like. This is x cubed, 1 over x, cubed root of x. On this program, or on these questions, a lot of times there's a number other than 1 there. And so remember, that's your A. Okay. So a lot of times they have 2 or 3, I noticed. Anyway, let's just get on with the lesson. Okay, so for this lesson, you're going to be doing basically the same thing as in part 1. You're going to describe each transformation, write the function of the transformed picture. You won't have to actually graph, but you will have to recognize graphs, recognize equations, change equations, just like the last time. So here we go, describing each transformation, just what happens. Now remember that it's not a vertex point, but it's the center point. The center point for the parent function is right there. The center point for the child function, right there. Okay. Notice they're facing the same direction. Okay. There's no flip involved. If it was facing a different direction, that would be considered a flip, and that would be a reflection. There is no reflection here. To check if there is a vertical stretch or compression, you can check from the center point to one of the other 2 points, and it's over 1 up 1. If you get this one, it's over 1 up 1. So there is no vertical stretch or compression, which means there's no A. Okay, no visible A. A is 1. So we don't have to worry about that. But what does happen is this center point moves over here. So it moves 1, 2, 3, 4 spaces left, 2 spaces up. So those are our changes here. We have left 4 spaces and up 2 spaces. Okay. Once you have that, then you need to do the child function. Now this one is the x cubed, so our child function is right here. A, H, and K gets filled in based off what happens to make the green graph. Okay. The child function, not the parent function. Notice the parent function, it's pointing, has an arrow pointing to that one, the dark one. Okay, so I'm going to leave this blank, and this blank, and write everything else. So y equals a blank space for the A. If we had an A, we would put it there. This one, the parentheses, is cubed, and K goes after. So since we have left 4, left, remember left to right is your H. H goes in the parentheses with X. Okay, left to right, but it's opposite of the sign. So since this says left 4, well, left is in the negative direction on the graph, on the grid. Gosh, I don't even know my left from my right now. See, this is where I need the classroom. So you guys could say, Mrs. Heisey, isn't that right 4? Because I always mix those up. Right 4. Right is the positive direction of the x-axis, and now it feels right. Which means we need to have this be negative, and we plug in a 4 in the H spot, so it should say -4. Okay, so that's right 4. Now we have up 2, up, and I did that one right. Up, down is K. K is after the parentheses, okay? And it goes same as the sign. Okay, so same as the sign. So up is the positive direction on the graph, so +2. No visible a, so we don't have to write anything there. This would be our official function for the child picture, the transformed picture. So we described what changed, and then we wrote the equation for the changes. So you're going to have some problems where you get this and you have to write the changes, or where you get this and you have to write the changes, or where you get this and you have to write the equation, or if you get the changes and you have to write the equations. It's all kind of intermixed. Okay. Next one. This one kind of looks like that, except sideways. Okay. Sideways. That's called a cubed root. The other one's a cubic. They're opposites. They're inverses. Not necessarily opposite. They're inverses. So cubed root has the radical, but it has a little 3 inside that radical. That's called a cubed root. And there is a special button to give you that on your in your little math tools when you're typing it up. There's a little button that has a radical symbol with a little box there. And then in that box, you would put a 3, and then you could put anything there. If you have an A, it goes in front. But this is the button you would use to fill out a cubed root, just so you know. You can do this button for square root if you put a 2 in that box. Okay. Since we're doing a cubed root, this is my child function, so I'm going to go ahead and write that out over here. Y equals, leave a space for a if there's an a. Then we have the cubed root, x minus or plus something goes in there, and then the k goes after. So let's describe our changes. First check for reflection. Flips down, and if you notice, these are both facing up. If it flips down, it would be going the other direction. Okay. I have a hard time drawing these, so if I just did the wrong thing, just know that I do know how to do it. I just messed up there by doing that. Anyway, there is no reflection here because they're both the same direction. Now to check if there is a vertical stretch or compression, use the center point, compare it with the first points, so that is over 1, up 1. So center point compared with the first point after that, or the next point, over 1, up 1. They have the same. Since they have the same, there is no vertical stretch or compression. So we get, we just moved it left and right. So the center points from this center point. So going from this center point to this center point, there's a left 1, up 1. And I had to think about it just to make sure I got my right direction. Okay, left 1 and up 1. Okay, since there is no reflection, there's no negative out here. Since there is no vertical stretch or compression, we're not going to draw an A in here. You can put a 1, but we don't really put a 1 there. We have left 1, left, which is H. H goes with X. It's opposite of the sign. Left, since it's the negative direction on the x-axis, we want to make sure it says positive 1. And then up 1. Up is K. K goes after the parenthesis, after the grouping symbol. It's the same as the sign. So up 1 would be right there. This would be our function. These would be our changes. Easy peasy. Okay, the next one, you can see the parent function, but I need to move this down. Because the graph is so big, I could not put the child graph on the same one. It's too much to draw on one graph. So I put the child function down here. So this is called the rational or reciprocal, depending on what video you're watching, or what it says. Those are both used for this type of function. It's 1 over x. So if you're doing this, if you're typing this out, there's a button, which most of you have found, but some of you still have not found the fraction button. There's a fraction button, and then you could put stuff on the top and the bottom. Then you put stuff before and after as well. Okay. So this is how my picture, my equation is going to look if I have no A. So there's no vertical stretch or compression. I just put a 1 there. You got to have a placeholder. You got to have something up there. So if there is no A showing, or if there is no A, then you want to make sure to put a 1 there. Okay. Or if there's a reflection, you would put -1. Okay. And then we have x minus h. The fraction bar is the grouping symbol, so h goes on the bottom of the grouping symbol with x, and k goes after the grouping symbol, which is after the fraction. So I'm going to write that down before I forget. I'll put it down here because it's for this one. Okay, so that's set up and ready to go. I need to do my changes. So from here to here, notice we have asymptotes. You remember when we did this before, we had the 2 dashed lines that we had to see that can never be crossed. So we kind of go from the center, the intersection of the asymptotes, that is kind of our center points. That's kind of our vertex. And then if you notice the boomerangs, the swoops, however you want to call it, are both in the same 2 quadrants. So that means there is no reflection. And then going from our center point to this upper point here, it's over 1 up 1. So going from our center point to the upper point here, it's over 1 up 1. So since that doesn't change, then that means our A is going to be 1. So we could just go ahead and put a 1 there. There's no reflection. There's no A. There's no vertical stretch, no vertical compression. We don't need any of that. But what does happen, our center point goes from 0, 0 to over here. So from 0, 0, that is right 1, down 2. So those are the changes that we have here. So right 1, down 2. So I guess on these problems I didn't put a vertical stretch or compression. That doesn't mean you won't have problems that have a vertical stretch or compression or a reflection. That will still happen. So you could always refer to part 1 for those notes, or for a refresher on how to do a vertical stretch, vertical compression on the equation. Okay, so like if going from this point it was over 1 up 2 and my graph was drawn there, then this would be a 2 up here, okay, instead of a 1. The right is left, right, opposite of the sign. That's your H, goes in the grouping symbol with X. Right 1, right is the positive direction, so we want this to be minus 1. Okay. It's already minus, so there we go. And then down 2, which is K, which is after the grouping symbol, same as the sign. Down 2 is minus 2. This would be your function or equation for this picture. Okay, so this is part 2 of parent function transformations, and that's it for the week. Have a good day.